Alright, here I go again with my infinite screens. We're going to be looking at question number 20 here. Again, I'm going to use software as my means of calculating. I'm not in, I'm on my Linux machine, so I don't have Excel, but I have LibreOffice, and so everything I'm going to use in LibreOffice is exactly the same as Excel. And what this wants us to do is look at some z-scores that come out. And now what we have here is the lifespans of a species of fruit fly have a bell-shaped distribution with a mean of 36 days and a standard deviation of 5. And so that's talking about the population. And what we're going to do is we're going to pull out and do some z-scores. So I'm going to actually take the days that we're looking at, and I'm just going to make some data points for them. And so we have, what, 39, 35, and 50 is the data we're going to look at. 39, and I have to keep looking back here. 39, 35, 50. 39, 35, 50. And so this is the data we pulled out. Now I guess over here I'll put my mean and my standard deviation as reference cells. And so my mean is 36 and my standard deviation is 5. So I'll just put those there as a reference. And so this is my data, and this is be my z-score. I'm going to insert another column here. Insert column before. And that's my mean and my standard dev. And so to calculate the z-score, we remember it is the data point. So in this case, it's B2 minus, now I have to anchor the mean. So $E $2. Notice I put it in parentheses. And so that's the difference between my data point and the mean divided by the standard deviation, which again is $E $3. And I have a z-score of 0.6. And if I bring this down, that gives me the z-scores for all of the data. And notice how it updated. It changed the B but kept the E's the same because of the dollar signs. This is something I'll emphasize as we continue through. The negative value says that this is before the mean. You know, if the mean is 36, 35 is before. And the positive value says it's after. And so these scores are close. They're within one standard deviation on either side, so they're within that 68%. But this 50 is an unusual score, almost very unusual. It's near 3, so it's getting close to unusual or very unusual, and so that's how we would go about calculating z-scores and letting z-scores tell us about the data. And so let me put these in here and get to the last part of the question. 2 seconds as I go back and forth. Negative 0.02. And what was it? It was a 2.8 for the last one, I think. Right. And then so select all of the spans that are unusual. Well, none of these are unusual. Oh, incorrect. Oh, yep. Notice unusual. Not very unusual. Sorry, my bad. I was getting all excited. There were no very unusual, but the things from 2 to 3 fall in the unusual. And it's important to look at our wording. All right, and so what we want to do here is we want to think of our bell curve now. And we want to look at where things are percentile-wise. So I'm going to come over here. Let's see if I still have my Blackboard open. And we're going to think about how these things distribute. And if this is a normal curve, Jeff should learn to draw these better. It's funny, I've been drawing these for ages and I still, my left-handedness shows. If that's the mean, then at one standard deviation, it's, well, 50% of the stuff is before and 50% is after. Because it's symmetrical. Because this is a symmetrical curve. Yep, making sure we have the right thing there. Because it's a symmetrical curve, symmetrical distribution, the mean, median, and mode are the same place. Being median, 50% of the stuff is before and 50% of the stuff is after. And then as we move up a standard deviation, we get particular percentages of stuff. So this is -1 standard deviation, this is +1 standard deviation, this is -2 standard deviations, this is +2 standard deviations. Well, I'm going to jump over to the data here again. Again, you'll get the infinite screens for a second. And what we know is the standard deviation is 5. And so what this is actually saying is, what is the percentile 2 standard deviations less than the mean? And then this is what is the standard deviation, or what is the percentile 3 standard deviations greater than the mean? And 46 is what is the standard deviation 2, or as the percentile 2 standard deviations. And so this puts it together. Let me come back here. Sorry for as I talk, as I switch things around. And so what we get is we can map all of our data to any standard normal curve. And now we have our mean value being 36. Then +1 standard deviation will be at a value of 41. +2 standard deviations would be 46, and +3 standard deviations would be 51. -1 standard deviation would be 31. -2 standard deviations would be 26, and -3 standard deviations would be 21. And so these data values represent that. Well, if this is 50%, and this bit was roughly 14%, then everything up to here is 50% minus 14%, or roughly 36%. Now what I would do when doing these in Pearson, again, let me come back over here. Whoops, that's not the one I want. I want the screen. Over here. Let's see if I can find, always have an odd point trying to jump screens here, because this gave me, let's see, here we go, into the e-text. Sorry about the delay here. Internet's the internet, you know. We're all dealing with it somehow. And my empirical rule. Because I've noticed the book in Pearson uses 2 different values, this depending on how accurately they want to show it. And we will find better ways of doing it as we go through. Oh, there it is. This is. And so notice the gaps through in here. If this is 68% wide, this tells us how much stuff. So if we have 50% here, and I fall back, I would subtract the 34.13. And if I fall back to here, I would subtract the 34.13, and I would also subtract 13.59. This tells us how much percentage falls between the data points. And so the standard deviation has a way of telling us our percentiles of how much data is in there, but you have to anchor it versus that 50% mark, because this curve actually goes on infinitely, and that'll be a problem we will fix very shortly as we go infinitely. An example is we have the 2 standard deviation. There's 95% of the data in it, with 2.5% before and 2.5% after, because it's balanced. So something that's on the negative 2 standard deviations, it's the 2.5 percentile. Right? How much stuff comes up to that line? But to figure out that line, you have to subtract from the 0 point. All right, that's my little tip for today. Cheerio.